Hello. Today we are going to know a lot about Archimedes. Before we begin, please subscribe to the channel. 3, 2, 1.
Archimedes was a Greek mathematician, physicist, astronomer, engineer, and inventor, and he is famous for the Archimedes principle. He is also famous for Archimedes' screw, hydrostatics, levers, and infinitesimals. Did you know? Archimedes was asked by King Aaron the second to test a golden crown of its purity without melting it. Archimedes was getting into his bathtub, thinking about the question, when he noticed the water level rising. He ran out crying Eureka, running by the streets but without his clothes. Archimedes stated that whenever a solid object is wholly or partially immersed in water, it experiences an upward force by water. This is called buoyant force, which displaces certain amount of water. The amount of water is equal to the volume of the object. Archimedes screw. The Archimedes screw is a simple machine used to lift water or other fluids from a lower level to a higher one. It consists of a helical screw inside a hollow tube, which is rotated manually or by a motor. As the screw turns, water is trapped in pockets between the threads and gradually moves upward. Functions are used for irrigation, draining low-lying areas, and moving liquids or grains. It's designed as a screw-shaped surface inside a cylinder or an open trough. How it works? The screw is placed at an angle with its lower end submerged in water. As the screw rotates, water gets caught in the screw threads. The water is carried upward and eventually exits at the top. Its applications are ancient irrigation systems, drainage of water from mines and lowlands, modern adaptations in wastewater treatment and hydroelectric power plants. Claw of Archimedes. The claw of Archimedes is a weapon that he is said to have, designed in order to defend the city of Syracuse, also known as the ship shaker. The claw consisted of a crane-like arm from which a large, metal grappling hook was suspended. When the claw was dropped onto an attacking ship, the arm would swing upwards, lifting the ship out of the water and possibly sinking it. There have been modern experiments to test the feasibility of the claw, and in 2005, a television documentary entitled Super Weapons of the Ancient World built a version of the claw and concluded that it was a workable device. Value of pi. It is a very significant discovery in the field of mathematics. Archimedes shows that the value of pi is greater than 223/71 and less than 22/7. The latter figure was used as an approximation of pi throughout the Middle Ages and is still used today when only a rough figure is required. The value of pi is one of the most fundamental constants in mathematics and science. It represents the ratio of a circle's circumference to its diameter. Regardless of the size of the circle, this ratio remains constant. Archimedes' contribution to pi. Archimedes of Syracuse circa 287 BCE to 12 BCE was one of the first mathematicians to approximate pi using a geometric method. He inscribed and circumscribed polygons around a circle and calculated their perimeters. By increasing the number of sides, he narrowed the range within which pi could be found. His estimate 223/71, pi less than 20⁷, was the most accurate known for centuries. Modern approximations Today, pi is known to millions of decimal places thanks to computers. The commonly used approximation, 3.1416, is accurate for most practical purposes. For advanced scientific calculations, more precise values are used. Pi appears in various fields, including geometry, calculating areas and volumes of circles and spheres, engineering and physics used in wave mechanics, electrical engineering and fluid dynamics, astronomy and space science, calculations involving planetary orbits and distances, cryptography and computing. Pi's randomness is useful in security algorithms. Archimedes' work laid the foundation for future mathematicians, making pi one of the most studied numbers in history. Search the equilibrium of planes to volumes. The first book is in 15 propositions with 7 postulates, while the second book is in 10 propositions. In this work, Archimedes explains the law of the lever, stating, magnitudes are in equilibrium at distances, reciprocally proportional to their weights. Archimedes uses the principles derived to calculate the areas and centers of gravity of various geometric figures, including triangles, parallelograms, and parabolas. Archimedes' heat rays refer to a legendary weapon that the ancient Greek mathematician Archimedes supposedly used to defend the city of Syracuse from Roman invasion. In the 3rd century BCE, the idea is that Archimedes arranged a set of polished bronze or copper mirrors to concentrate sunlight onto Roman ships, setting them on fire. While the concept is fascinating, there is no definitive historical evidence that this actually happened. Ancient accounts, such as those by the historian Galen, mention Archimedes' ingenious war machines but do not confirm the use of heat rays. Modern experiments, including those by MIT and the TV show Mythbusters, have tested the feasibility of this weapon. Some tests showed that while it is theoretically possible to ignite wooden ships under ideal conditions, practical limitations, such as maintaining perfect focus and the movement of ships, make it unlikely to have been an effective battlefield weapon. Would you like to know more about the science behind it?